I'm John Damask. Thank you for the nice introduction. I won't spend too much time repeating what you already said, but basically I've got a background in software and data engineering and bioinformatics. Part of my career was consulting and startups, and part of my career was at NIBR. Most of my time at NIBR was spent on the science side of the organization, and then in 2016 I moved over to the IT side to lead the cloud team in the first phase of their cloud transformation. So if we're not already connected on LinkedIn, please do so. Reach out to me. I'd love to hear from you. And for the geeks in the audience, I've included my GitHub. So today I'm going to tell you a bit about Flagship Pioneering and who we are and how we go about creating companies. My team is Flagship Informatics. So I'll explain how we operate. I'll tell you a bit about how AWS is really a key foundational piece to the digital footprint of all of our companies. And then we'll get into some common situations and solutions. And I'll end with some things that we would like to see from AWS in the future. So Flagship is a company that creates companies. We're a non-traditional VC in that the ideas for our companies come from within. So you have this sort of funnel on its side in this screen. And starting at the left, we have explorations, which are the idea generation phases that go on with our origination teams inside of the fund itself. And we'll have dozens of these over the course of a year. A subset of these move on to get seed funding from Flagship, and they're prototype companies or protocos. And this is where they test out the feasibility of the scientific basis as well as the market opportunity. When they get their Series A funding, they become newcos. And this is where they're able to implement their platforms and start executing and building it out. The funding typically will give them a runway of about 2 years. Maybe they can get up to about 20 people, give or take. These are averages. The graduation from newco to growthco is the Series B funding. And this is where Flagship brings in external investors to participate in the funding rounds, but we maintain a majority stake in these companies. Growthcos are poised for growth. They're enterprise ready. This is the time where they bring on a CEO and build out their operational capabilities. And this is where they sort of separate from the mothership, if you will, because they're a self-sustaining organization. For context, Flagship's been around for 20 years, created over 100 companies. There are currently over 50 in our portfolio with over 50 clinical programs. We've had 20 companies have initial public offerings since 2013, and $30 billion in aggregate value has been created across the companies. Now, interestingly, if you add up all of the employees across the Flagship ecosystem in Cambridge, it turns out we're one of the main employers in the city with over 4,000 people across our portfolio. So I just pulled out 3 of the companies to give you examples. Everybody on this call knows who Moderna is. Their platform is using mRNAs as therapies. In Biosciences is our latest company to come out of stealth mode. This is an agricultural company that's focused on the relationship between insects and plants, and how can we use that to improve agricultural practices by increasing crop yields while simultaneously lowering the use of pesticides. Celerity is a company that's focused on understanding cell state and behavior and how that relates to disease, and then developing therapeutics that modulate that behavior. So how we support our companies. It takes a lot more than great science to make a great company. And what we've learned is that it's probably more advantageous for Flagship to create platform teams to help with the ancillary activities that aren't scientifically focused for these companies. So in this slide, you have Flagship on the left and an example protocol on the right. The founder is an associate or a principal from Flagship. When they get funding for the company, they embed in the company and lead it through the first few years. Early hires will include the scientific platform head and the data science head and a couple of bench scientists. Now, whenever this company has questions around staffing or finance or building out their patent portfolio, there's a dedicated team within headquarters that they can work with. And down at the bottom, you see digital. And that's the team that I'm a member of, which is Flagship Informatics. Now, we work with the companies on everything from foundational IT and networking to data science to data management. And we work in more meta level concerns as well, and like helping companies plan out their digital strategy, helping them decide when they should be bringing on certain hires in the computational space, what level they should be at. And we help with things like vendor selection. Our work in the earlier stage companies is very hands-on and a supportive capacity. And then as the companies build out their capabilities, it naturally shifts into more of an advisory role. And we also work to build out the community of data scientists and computational folks across the portfolio. So you can basically think of a big Slack channel with a couple of hundred informatics people. So it's very easy to ask and answer questions. Now, of course, in Flagship Informatics, we're not the experts, but we're in a privileged position because we get to talk to all of these companies and see where their patterns are. So we work to create a feedback loop where we can listen and learn from the later stage companies and then bring those learnings back into the earlier stage companies through a series of iterative experiments. So if you squint your eyes, the digital components of a biotech company largely fall into three areas. It's your foundation, your business systems, and your scientific systems. And what we've found is that there's really not much differentiation in capabilities as far as early stage companies are concerned in the foundation and business. So we've created a standard stack of SaaS applications and AWS for all of our companies. And as I say in the title of the talk, these companies are born in the cloud. So there are no data centers. There are really no servers on site at our companies. They don't build out internal HPCs generally. And we typically advise against building out internal storage. We say use the cloud until you have a good reason not to. So getting into this foundation, each of our companies gets their own AWS account, and we leverage something called the AWS Biotech Blueprint to give them standard configurations. Now, this is a great contribution to the community, and it was written by Paul Underwood from Amazon's startup team, as well as our friends at Third Rock Ventures and their platform team. And it's a real enabler for our companies because we could launch a company at 8 a.m. and have their cloud environment up a couple of hours later. It's essentially a big cloud formation script that sets up things like networking components according to best practices. So we have the VPCs, the subnets, the NAT gateways, et cetera. It configures things like standard CloudTrail buckets, puts on a few CloudWatch alarms. So it gets us out of the gate really fast. We add a couple of things to it. We turn on Guard Duty and Security Hub. I'm big fans of those services. We add some budget alarms just to keep an eye on runaway costs, recognizing that a lot of our companies have people who are experts in their area of data science or computational biology, but may not be experts in the cloud. So we want to protect them. We also put on some IAM roles, and I'll go into some detail about how we use those later. And then we have an increasing menu of infrastructure as code templates that can be shared across the portfolio. Okay, so now we'll get into the meat of the talk, which is just some common situations that we encounter and how we go about solving them. I'm not going to read through this slide, but it's left to right. We've seen it enough across our companies so that when we hear certain things, we have certain answers to try solutions. As we know, there's no one size fits all in the cloud, so everything is a bit fungible, if you will. But I want to call out the first two items here on the left. And that is, if one of our early stage companies asks us if they should hire an AWS expert, our response is no. And this is because we view AWS expertise as an enabler, but it's more of an operational issue. It's not going to add value to our companies in their early years because they're not building out software. That being said, they need AWS expertise. It helps squash the learning curve. And it helps them implement the designs that they're sort of imagining. So we feel that our companies get more bang for the buck working with AWS consulting partners. The second situation that happens a lot with early companies is that they want to establish collaborations, either with universities or perhaps they want to hire a specialized consulting firm to help with a particular computational biology problem. And then they'll ask us how to give these people access to their accounts. And we feel that it's easier to segment activity by account than it is to slice and dice IAM permissions. So we typically just spin up separate accounts and then take advantage of AWS organizations and consolidated billing. All right, so we'll go through 3 through 7 in the next slides. The first one is, how do we get data from our CRO? Excuse me. And this situation comes about because our young companies aren't building out their sequencing capabilities very early on. We're trying to keep their CapEx costs low when there's an opportunity to outsource. So they often outsource deep sequencing or RNA-seq to a CRO. Now, the situation we've seen come up is that the pattern for the CROs to get the data back to the company is a bit outdated. So on the left, you have the CRO, they have the sequencer, they put the data up on a web server, and then they tell our companies to go ahead and download it. Since our companies are born in the cloud, practically what that means is somebody has to fire up an EC2 instance, issue the wget or curl, it downloads to local storage. Once that's done, there's a second step to copy it to S3 so that it's in a more durable storage. So we feel that this is a bad design across the board. Humans are in the loop in areas where it could be automated. The transfer speed is dependent on EC2 size, and we've had people spend their afternoons trying to troubleshoot their Wi-Fi or their networks, only to find out that if they upped the instance size from a T2 micro to something much larger, the transfer speed increased. But of course, then they're over provisioning and spending for it. Also, NAT charges are a killer. The best practices that we preach is that when you stand up an EC2, it shouldn't be exposed to the public internet, so you should put it in a private subnet. But if you do that, you're downloading hundreds of gigabytes or low terabytes, the NAT charges will get substantial. And we've seen 5-figure charges come up for large transfers. So a better way to do this came about from a conversation that I had with Paul Underwood, and I thought his solution was very elegant in its simplicity. It's based on the assumption that CROs probably have AWS accounts, even if they aren't fully using them. And we found this to be true. So in this case, we have Dave at the CRO who does have an IAM object. So we'll ask him for his AWS account ID and his IAM object name, and then we'll add that to a bucket policy we attach to a bucket in our company's account. Then Dave can simply run an S3 sync command and put everything up. Now, one of the caveats here is that S3 sync requires full CRUD, so we don't want our companies to be doing work in buckets that are exposed to people outside of the company. So we're taking advantage of same region replication, which is something that Amazon released fairly recently. It's the same technology as cross-region replication, but it's an automated way to copy data from the landing bucket to a work bucket that's deeper in the account, and we can make that more secure. So this has a lot of positives to the design. I think S3 Sync is an often overlooked but very powerful tool, in part because it takes care of multi-part uploads for you. So as I say, Dave can run a single command and it will manage hundreds of gigabytes, or even we've seen up to 3 or 4 terabytes being transferred successfully this way. The same region replication is great because it's automatic, it's fast, it gets humans out of the loop. And importantly, for the security posture, our companies don't have to create IAM users for random people at other firms and then share keys. The security is controlled by toggling that bucket policy on and off. The problem is that we find ourselves training the CROs, and we try to make this as simple as possible for them. They don't have to make any changes to their AWS account. We simply give them a command line and say, paste this into your terminal, but yet we still find ourselves in sort of a supporting mode. Okay, so the next use case comes from something that you're probably all familiar with, and that is a lot of instrument software is rich client applications that runs on Windows. So on the left here, we have one of our companies with a low throughput instrument, could be a plate reader or a microscope, and on the right, we have their cloud account. The biologist needs to use the software to see the data, but we want to get the data out of the instrument and onto the cloud as soon as possible. So scheduled copies to FSX for Windows over a VPN tunnel works very well. A lot of the instrument software we've seen works just fine on Amazon workspaces, and this is good for the wet labs because it's a familiar working environment. They don't have to learn anything about the cloud. We just give them a client, they can work. Another benefit to this is you can actually map that same drive through that VPN tunnel to internal workstations. And we found this valuable because occasionally we have software from vendors that requires a hardware dongle for the license key. So it takes workspaces out of the running. But this works well for us. So this is great for the wet lab, but we feel it's not great for overall data management. And that's because we don't recommend our companies build out their storage capabilities in AWS using these traditional technologies like Windows file systems. So that gets us to the next question, which is, where should my data live? And we all know that there are a lot of options on the cloud. So our guidance starts with S3. We tell our companies you should make that the center of your data universe. For a number of reasons. Its robustness, its availability, and how well integrated it is with other services. We also tell our companies, if you're using S3 for data buckets, then turn on versioning. Even if it's write once, read many data. You want versioning on because it acts as a protection against accidental deletes. We're also impressed with Athena. For those of us who have a background in databases, we find that it's very powerful to throw a Hive table on top of a bucket and be able to interact with the information using SQL. And in fact, we're finding that this use case is valuable in this space because many times computational scientists will read a paper and then download a data set. It'll be in a delimited file, and they'll want to explore it using SQL. So we'll suggest trying Athena before spinning up an RDS instance. Moving on, you've got EBS volumes. Always use data volumes with your EC2s. And importantly, we tell our people to treat it as scratch space. For EFS, to date, we've only had cautionary tales. It is a commonly used service, but it's a very expensive service. And when it's mishandled, it could result in very high bills. We've seen extremely high bills come in a couple of companies where well-meaning informaticians who weren't familiar with S3, but were familiar with NFS, spun it up and started downloading 10 terabytes, 15 terabytes worth of data. And you only realize that pain when that bill comes in, which is one of the reasons we now have budget alarms on all of our accounts. FSX for Windows, I just described. It has a cousin, FSX for Lustre. Completely different technology. Lustre is actually quite exciting because it's very fast, it's easy to set up, it works great with batch and parallel cluster, but I think the killer feature of this service is its integration with S3. I love the idea of being able to spin up a file system and have it automatically hydrate from an S3 bucket. And then you can configure it to write back to an S3 bucket as well. So you can imagine this file system coming up and down. So it's still early days for us in terms of exploring Lustre, but we're looking at it for use cases outside of the HPC space. All right, so it's important to talk about anti-patterns too. The first one is not blocking S3 public access at the account level. It's just, it's an accident waiting to happen. It's a single click and it's part of our SOP, and I encourage you to take a look at your accounts. If it's not set, make the decision to do so if it makes sense for you. EBS volumes. Persistent problem is that informaticians are used to having their workstations as pets, right? They customize them, they make them suitable for their work, and they use them constantly. The risk is treating EBS as if it's as durable and reliable as S3. In fact, it's not. And then, of course, the bane of all of our existence is orphan volumes that wind up hitting your bill very heavily. So you can either have tagging policies or automated tagging, but just make sure that when you create your EBS data volume, you give it a name at least. The more traditional file systems, our recommendation is understand what you're getting into before you fire it up, because unchecked growth will lead to very expensive AWS bills. But the fact of the matter is, these aren't going anywhere in the computational sciences, right? Being able to mount a drive is really ingrained with data science, computational biologists, informaticians from my generation. All right, so let's move on to another use case, which is we have a central team who needs to access multiple AWS accounts. So on the left, you have Alice from the finance team in Flagship, who needs to handle the billing for a number of companies and get into their accounts. Now, there are a few ways to handle this. You could create Alice IAM objects in each of the account, but that's bad for operations. Excuse me. You can create a generic finance user in all of the accounts, but that's bad for security. So when we chose the route of doing this cross-account roles, which is considered an Amazon best practice, it's a little quirky conceptually when you first get into it, but once you've done it, and it starts to make a lot of sense, and it's very flexible and very powerful. So in this case, Alice doesn't need to know anything about AWS. She simply has a bookmark for the flagship account, and she authenticates to that. And then she has another bookmark for her company's AWS account. And when she clicks that bookmark, behind the scenes, the accounts are talking, the IAM services are talking. She gets her temporary credentials, then she sees the management console for one of her company accounts, and she can do what she needs to do in the billing area. This same pattern is used for SecOps. It's just that the permissions in the target account are different than with finance. We use the security audit job function, and we add a few things to that. It's interesting that this pattern can be used within a single account, and this is powerful for startups because when you think about the security principle of least privilege, it makes more sense as the complexity of your environment increases. When you have a startup, so you have one team and they're all working on the same thing, least privilege, in my mind, isn't as important because it can create disruption in the work, especially because our startups don't have help desks. They have managed service providers, and the SLA on a ticket for a service provider might be 24 hours as opposed to 1 hour. So in this case, we'll give certain people elevated rights, but to prevent against fat finger mistakes, it's a deliberate step to elevate those rights. So in this case, Jerry has limited rights, EC2, RDS, whatever. Let's say he needs to fire up SageMaker or something else. He gets an access denied, but he can assume the admin role, and then he has temporary admin rights to do what he needs to do. Okay, more on the data science end user piece is our computational folks are very excited to get into their accounts, very excited to be able to stand up an EC2 of any size they want, but of course that's just a shell. So building out their own systems can take a long time. So Steve Marshall, who's a member of Flagship Informatics, has built out some really nice CloudFormation and launch templates to do this for them. So it's good for the user because it's a turnkey solution. They don't have to have AWS experience to get this working. And it's good for the ongoing operations and security of the account because it ensures that EC2s are going into the right subnet and they're reusing security groups. And it's also very useful to script this for batch environments, which is something Steve has done as well. Okay, so moving forward, I want to talk about a few things that we'd like to see. The first is I'd like AWS to fully embrace the multi-account model. I've been a fan of multi-accounts since the NIBR days, and I still feel that it's a very powerful way to go, to think as an AWS account as just a container for stuff. There have been a lot of great steps forward in this, starting with organizations, and then with Control Tower going GA last year. That was very powerful. But one of the challenges we see is sometimes the services aren't operating the way that I would expect them to as a customer. And I think a perfect example of this is that Transit Gateway and Control Tower don't yet play nicely together. When you configure Control Tower for multi-accounts, you have a parameter for a CIDR range that goes into the account factory. But what this means is that every account that gets created from that factory has the same CIDR range. So you don't have network segmentation, which makes routing a problem. I would like to have a transit account so we can have a single VPN endpoint so all of our users connect to that, and then from there the routing takes place. Currently, we can't do this out of the box. I also feel that support needs to follow the organization and not the account. I think with enterprise customers, this probably isn't a problem, but when you're a startup and you're watching your bottom line very closely, you have to make the decisions about, should I have basic, should I have developer, should I have business? If we have a situation where there are two accounts for our company in an organization, a master account and a member account, we could sign the master account up for business support, but it doesn't flow down to the member account. Now, what happens is that somebody in the member account has a question, but they can't ask for help. We have to figure out a way around that. I would like business support to target the organization. Another thing that I would like to see is fraud detection and automatic actions. So think of it as more like your credit card company. We had a situation a year ago that's all too common where API keys were accidentally exposed in a public repo and the account was popped. Thankfully, nothing bad happened, but by the time we found out about it, the actor had already been in and out, and bad things could have happened. We just dodged a bullet there. I think it would be nice if I had a configuration option to tell AWS, if you see certain anomalous activities, then don't execute on the action, but send me a text message or some sort of approval. Again, very similar to what you get from your credit card companies. I think there could be power in adaptive services. AWS has the data, they've got the ML tools. An example of this is IAM access. I would like to see that constrict over time without having a human in the loop. I think that the job function policies that have been published by AWS are powerful, but if you take a look at something like Power User, it effectively gives you access to everything except IAM. If you look at the IAM console for the Access Advisor, you could see that Sally is using 3 services all the time, but she's never using the other 104 services or whatever AWS has. I would be willing to tell AWS in a configuration option, go ahead and restrict those permissions over time based on the behaviors that you see. I would also like to see adaptive services offered for right-sizing EC2s and RDSs. We think about adaptive services in terms of horizontal scaling. I think it would be nice to see it in terms of vertical scaling. If we have a P3 running and the CPU is never above 4%, it would be nice to have an option to tell AWS, if you see something like this, I'm going to authorize you to make the change. The next one is about data science. It's been really impressive to watch the launch of higher level managed services by AWS for ML and AI, but all of these target developers, which is great and it's powerful. But in biotech, we don't need recommendation engines. We have some of the best data scientists in the field across our portfolio, and they continue to roll their own. So they stand up the EC2s and then they build them out the way they know how. Part of this is just sort of interaction to make them aware of the higher level services. But I do think that there needs to be more of a community push to get involved, get in front of these computational people, or customer development, if you will. And I think that starts with more support for R. And then the last thing is I would like AWS to be working with CROs to demonstrate to them how using AWS smartly increases their value proposition. And I want you to do this simply to take me out of the business of helping them. Okay, so I want to end on the great stuff that AWS is foundational to all of our companies, and it's terrific because it allows us to innovate so fast. The startup incentive programs are fantastic. All of our companies go through the Activate program at some point in their life. And the AWS startup team are just awesome partners. So shout out to Elliot Minchek for putting it together, and specifically Paul Underwood, who's just a rock star solution architect, and Alexis Moinpour, who's part of the business development side, who is always extremely responsive. And she and Elliot and Paul have really gone to a great extent to learn what we're trying to do here in Flagship and make sure that AWS is following along and giving us the support we need. So thanks a lot to AWS, to Rajesh for putting this together. We know how hard it is to build communities, so I think it's great that you guys are doing it instead of leaving it to us. And Paul and Alexis and Elliot again. From Flagship, I want to thank my partner in crime, Steve Marshall, and Remy Avar, who's the CIO and Chief Digital Officer of Flagship. He was the one who had the vision for this team and put it together. And of course, I want to thank all of our portfolio companies because it's been such a fantastic year to be able to learn from some of the brightest, most ambitious, idealistic people in the business. It's been a really fun year.